So today I'm going to be presenting on aquatic resource niche construction in the Soconusco region of Mexico, which is the topic of my dissertation. And before I start, I just want to acknowledge the continued support of my advisor, Dr. Emily Jones, as well as the rest of my committee at the University of New Mexico, Dr. Bruce Huckle, Dr. James Boone. And then also I want to thank for collections-related assistance and support, Dr. Barbara Voorhees, Dr. Heather Thacker, and Dr. Douglas Kennett. And then I also just want to thank the researchers who identified the faunal identifications that I'm going to be discussing in this presentation. Dr. Thomas Wake, Dr. Richard Cook, Dr. Elizabeth Reitz, and Dr. W.I. Follett. So this presentation is really the first I'm giving on the topic of my dissertation research. And I was interested in this question of why around the world you see examples of societies who rely on coastal resources and either never adopt agriculture or adopt agriculture later than their surrounding contemporaries. So the Soconusco region of Mexico is a really interesting case example, just because there's a very long history of coastal resource exploitation, dating back to the Archaic period prior to intensive agricultural consumption, and then also extending into the period where agricultural products become more important during the formative period. So my dissertation is really focused on understanding if the Chantuto society, who lived during the Archaic period in the Soconusco region, practiced niche construction behaviors that maintained coastal niche stability. And I'm just going to go briefly over what I mean by a niche and niche construction. So what is a niche? And a niche consists of the biotic and abiotic components of the environment, with the example here being of a mangrove environment, as well as the relationships between those different components, and the relationships become very important. In niche construction, an organism modifies its relationship with the environment through spatial or temporal environmental changes, either increasing or decreasing fitness. So in this case, you can see humans have constructed a home in this niche, perhaps from mangrove trees. And in niche construction theory, oftentimes there's a sort of larger focus on coevolutionary relationships, such as you see with domesticated animals or plants, but the behaviors of habitat modification, like you see with this house here, or management are also important, especially when considering the relationship between foragers and wild resources. So I'm focusing here really on how archaeologists can identify human niche construction behaviors that help to maintain niche stability. So then how can we start to identify these niche construction behaviors? And sort of as a preliminary method of characterizing potential changes in the niche stability of fishes in the Soconusco region from 6 different archaeological sites, I use these 4 measures of abundance, richness, evenness, and nestedness. And I'm just going to go over these real quickly for anyone who might not be familiar with them. They're sort of measures used in zooarchaeological analyses. So NISP is the number of identified specimens in an archaeological assemblage. So here, 5 bones identified to a Pacific fat sleeper fish would be an NISP of 5. Richness is the number of different taxa. And so here we have 2 different species, so it would be an N taxa of 2. Evenness is the degree to which an assemblage is dominated by a single taxa. So if there is a similar distribution of specimens across different taxa, the assemblage is going to be more even. And then nestedness is just a measure of community structure, and I use it to see if different taxa are represented at different time periods and at different sites. So to address whether the Archaic period Chantuto society maintained fish population stability as a niche construction behavior, I use these measures to analyze published fish assemblages from the Soconusco region from both Archaic and later formative period sites when agriculture was more incorporated into the diet. And I include fish assemblages from 6 sites spanning the Middle Archaic with Cerro de las Conchas, and each of these sites is sort of demarcated by the purple star. The late Archaic period, Zapatillo and Tlactuachero, and the formative period, Paso de la Amada, Salinas de la Blanca, and La Blanca. So I'm just going to start with the relationship between NISP and taxa for these assemblages. And the linear relationship when logged between these two measures indicates that there's not really a substantial change in overall exploitation of estuarine resources moving from the archaic to formative periods. While there is a decrease in richness, this can be caused by a number of reasons, and sort of moving on to evenness and nestedness sort of help to delineate why this decrease in richness might be occurring. So moving on to evenness, there is a relatively low evenness values for two of the sites, Tlacuachero and Paso de la Amada. And this low evenness value is really due to large proportions of, in both cases, Pacific fat sleepers at both of these sites, and then also gar at Tlacuachero and catfish at Paso de la Amada. The rest of the sites are relatively even in their distribution of fishes. Moving on to nestedness, the results of the nestedness analysis indicate that when comparing the archaic period levels of the shell mounds with formative period fauna, the fauna appear to come from the same community. In contrast, when analyzing the nestedness of the archaic period and ceramic period layers from within each shell mound, and this is the second table on the slide, the results are non-nested. And this is rather significant because the archaic period shell mounds are positioned around the same estuarine system. So you would expect that people are going to be exploiting the same sort of fauna from this estuarine system. But in fact, they're exploiting very different faunal species at different times. So it's important to note that there is evidence for a rise in sea level towards the end of the Middle Archaic period, and this is probably the explanation for the non-nested result for Cerro de las Conchas, as it changed the species composition in that portion of the estuary. But there's not evidence for a similar environmental change during the other periods, and this sort of indicates that the Chantuto people were targeting different species during the Archaic period than the formative period, and sort of emphasizes that despite the continuities in aquatic resource extraction, we also have significant change in the species composition of the exploited species. So what does this sort of tell us about whether the Chantuto society used niche construction behaviors to maintain coastal resource stability? So the sort of conclusions we can draw from the aforementioned analyses indicate there's stability in the fish population, but also a change in the species composition of the fish that are harvested over time. And this leads to two general hypotheses that I'm testing for my dissertation. So the first one is that the change in species composition is related to changes in fish management practices related to human niche construction behaviors. And then the second hypothesis is that the switch in harvesting could reflect a change in gender roles as there was an increased investment in agriculture. And the second one is sort of building off of a model first proposed by Voorhees and Kennett in 2011. And I'm going to talk about that in a bit more detail. But first go into the first hypothesis. So for this first hypothesis, what might we expect in order to test this? So we should expect to see population stability within the fish population. And I'm going to be measuring this using carbon and nitrogen stable isotope values. But basically, there should be no relative increase or decrease in the dietary niche, and the sort of food web connections shouldn't change in any large way. If the Chantuto Society are harvesting fish to maintain this population stability, they should be harvesting them when fish are past the age of maturity and also during periods of abundance when the fish population is going to be impacted the least amount, so during the dry season in this region. And I'll talk about this a little bit at the end, but I'll be measuring this using carbon and oxygen stable isotopes of fish otoliths. So moving on to the second hypothesis that I'll be looking at. Alternatively, if there's no evidence for these fish management practices, the change in species composition might reflect a change in gender roles. So Voorhees and Kennett in 2011 proposed that there was a switch in harvesting that could reflect a change in gender roles as there was an increased investment in agriculture. So as agricultural production intensified, men concentrated their efforts in agricultural production and occasionally would make fishing trips during the dry season, while women continued to forage along the coast, mainly during the wet season. And this sort of shift in gender roles comes in conjunction with the shift in the season of clam harvest, which they showed changed from a year-round preferring the dry season to targeting clams during the wet season. So if this model is the case, what might we expect to see in the fish? So again, we should see ecological stability within the fish population. There shouldn't be any large-scale changes, but we should see the sort of opposite seasonal pattern as seen in the clams, as men switch to occasionally fishing during the dry season, but otherwise the fishing and harvesting is being left for the women and children, mainly during the wet season. So I'm going to, moving forward, I'm going to be testing this using carbon and nitrogen stable isotope analyses of fish bones, and then evaluating the carbon and oxygen stable isotope analyses of fish otoliths to look at changes in the season of catch. And I've sort of completed the bone collagen analyses in about a third of the fish otoliths, so I have an idea of which of these hypotheses is going to sort of looks more likely to pan out, and hopefully I'll be able to present on that in the future. So thank you all for listening, and also to the Society for Ethnobiology for putting on this conference.